Good afternoon. Today we are starting with our first objective of pre-algebra. We are doing CO1. I can identify whole numbers, integers, and rational numbers. We're going to learn what all of those words mean and how to apply it to our numbers. With a number system as large as ours, it's helpful to have it broken down into categories. Here are a few of the categories with the most specific category listed first. So we have our whole number is a positive number not a decimal or fraction. So the number has to be a positive and it cannot be a decimal or fraction. Then we're going to get a little bit broader with our integer. An integer can be a positive or negative number. But still not a decimal or fraction. And then our broadest one is the rational number. So positive or negative number and it can be a fraction or a decimal that ends or repeats. So you can see how our categories get bigger and bigger as we go down. There is a fourth category, and the one that doesn't fit into any of the three above, it is a rational number. So a rational number can't fall into these other categories because it is a decimal that does not end or repeat. So if it is a decimal that goes on and on and on and on, it will be irrational. If it is a decimal that stops, like 4.25, it ends, or it repeats 4.252525252525, then it would be rational. But if it's one of those decimals that goes on and on and on and on, it is irrational. So here's a way to visualize how the four categories work. Notice how our irrational numbers are over to the side. So we have something like 4.916823.9 ... Those dots means that it keeps on going. So that's irrational. Any decimal that continues going is irrational. So now let's look at our rational integers and whole numbers. So if it is a whole number, it can be any set positive number. So 5, 9, 13, those are positive numbers. They are whole numbers. If it is a whole number, it is also an integer and also a rational number because it falls into those boxes. An integer can be the positive numbers, and it could also be negative numbers. So if it's just positive numbers, it's a whole number, which is also an integer, also a rational number. Integers are those positive numbers and negative numbers. There are no fractions and no decimals. So then when we get to the rational numbers, it could be something like 1/4. It could be something like 0.79 that ends. It could be something like 3.21 that repeats. That bar above means that it keeps on repeating. 3.21212121. So you can see whole numbers are also integers, also rational numbers. Integers are also rational numbers. And rational numbers, if it is just a rational number, It doesn't fall into the integer or whole number category. Another way to think about it is if you are a 7th grade student, that would be a whole number, or down here, who is a part of the middle school, which would be the integers. So if you're a student in the middle school, that is a part of St. Vincent de Paul, so that would be like the rational number. So we're in 6th grade, so 6th grade students that are in the middle school area, and we are in St. Vincent de Paul School. If you're a kindergarten student, you would just be in St. Vincent de Paul School. You would not also be in the middle school and in 6th or 7th grade. And if you're somebody that attends a school, a whole different school altogether, you go to Osseo Middle School, that would be the irrational number. That's off to the side, it's completely different. So let me scroll up so we can see what else we have. So simplify a number before making a final determination about its category. A number like 42/7 may seem like it's only rational because it's a fraction, but its simplified value of 6 is also an integer and whole number. So you want to simplify those fractions to see if it can go to a whole number. So always make sure you're simplifying your fractions. Classify each number as a whole number, integer, rational number, or irrational number. List all applicable categories. So 65 is a positive number, so it's not a fraction or a decimal, so we know it's a whole number. Oops. And if it's a whole number, we know it's also an integer and a rational number. Negative 12.7. Well, it can't be a whole number because it's negative. It can't be an integer because it has the decimal point. So it is just rational because that decimal point ends. So we know that it's not an irrational number because our decimal ends. We look at -1, it's negative, so it can't be whole. It can be an integer because integers are whole or positive and negative numbers. And if it's an integer, it is rational. So let's look at this one. It's got those 3 dots that goes on and on and on and on and on. We know that means that it's irrational because it's that decimal point that continues to go. Remember to be careful with your fractions to make sure that you are simplifying it to see if it is a whole number. So you need to finish working on this page, and let's look at our second page. So we need to answer each question. Some questions may not be possible. So let's look at our first one. What is a rational number that is not an integer? So if it's not an integer, remember integers cannot be a decimal or a fraction. They can be positive or negative, but they cannot be a decimal or a fraction. So if we want a rational number that cannot be an integer, we would want to pick something that's like a fraction, or it could be a negative or a positive, or you could pick a decimal that ends. Those would be rational numbers that cannot be integers because integers cannot be fractions or decimals. If we look at the next one, it says, what is a whole number that is not rational? Well, remember when we were marking it down, whole numbers are automatically integers and rational. So can there be a whole number that is not rational? That is not possible. Whole numbers are always going to be an integer and a rational, just like a square will always be a rectangle. And a whole number will always be an integer and rational. You're going to work through the rest of them and see if you can find an answer for that, for all of those. Some may be not possible. Let's look down at using a calculator I was showing us in class how we use the second button, and then we go down to where that square root is on our calculator. Well, let me turn this on and see if I can get this to work. So if we have our calculator, so to do the calculator for the square root, if we look at that first one, the square root of 225, we would do the second button and then go down to where we see that square root sign. And then our number is 225 and then equals. So we can see that it says 15. So our square root of 225 is 15. So now we need to decide, is 15 rational or irrational? 15 is a whole number, so that is rational. Our next one is the square root of 83. So I'm going to clear it. I'm going to go to the second, go to where that square root is, and then it's of 83. Now on my calculator, it ends after that 4 because it doesn't keep going on and on and on. Some other calculators, you'll see the number goes all the way across and then it stops. These ones keep on going. So the square root of 83, because it keeps on going, it's not just 1 or 2 digits past the decimal place. These ones are irrational. So the square root of 83 is irrational. So you're going to do the rest of the calculator portion. And then we have our bottom question. You and your parents are gathered around the TV one night watching the Discovery Channel when suddenly you lose your satellite signal. Not being used to interacting socially with each other, things are a bit awkward. Then you get an idea for a game. Each of you will take turns saying a number from one of the categories listed above. You can only say rational numbers, your mom can only say integers, your dad can only say whole numbers. The winner is the person who can say numbers from the category the longest. Assuming you are each familiar with the categories, who will win and why? So you're going to come up with an answer for that and explain it. And that is our first day's worth of homework for pre-algebra. So I hope you are well, and I hope to see you soon.